Non-ideal solutions. The solutions which do not obey Raoult's law and are accompanied by change in enthalpy and change in volume during their formation are called non-ideal solutions. Conditions for non-ideal solution. Number 1. PA not equal to P naught A XA, PB not equal to P naught B XB. PA and PB are the partial vapor pressures, so it do not obey Raoult's law. Second condition, enthalpy change of the solution is not equal to 0. So enthalpy change may be increases, may be decreases. Third condition, volume change should not be equal to 0. So after the formation of solution, volume may be increases, may be decreases. It must be noted that for a non-ideal binary solution, none of the component, neither solute nor solvent, follow the Raoult's law. The non-ideal solutions are classified into two types. Type number 1, solution having positive deviations. Type number 2, solutions having negative deviations. Solutions having positive deviations are those solutions in which the partial vapor pressure of each component, solute and solvent, of solution is greater than the vapor pressure as expected according to Raoult's law. So, positive deviations increases the vapor pressure of solute and solvent. If we draw the graph, then the graph shows slightly greater values of partial vapor pressures and total vapor pressure of the solution. Conditions for non-ideal solutions. The type number 1, condition for positive deviations. For positive deviations, first condition, PA greater than P naught A XA and PB greater than P naught B XB. The partial vapor pressure of solute and solvent increases. Second condition, the enthalpy change also increases. So delta H equal to positive. Third condition, the volume of the solution also increases. So delta V of the solution is equal to positive. Some examples are acetone and carbon disulfide, acetone and ethanol, acetone and benzene, carbon tetrachloride and benzene, carbon tetrachloride and chloroform, ethanol and carbon disulfide, water and ethanol, water and methanol, chloroform and ethanol, carbon tetrachloride and toluene. In positively deviated solutions, the intermolecular force of interactions becomes more and more weaker than the solute and solvent intermolecular force of attractions. Due to this reason, these have low boiling point than the solute and solvent. Negatively deviated solutions. This is the type number 2 of non-ideal solution. In this type of solution, the partial vapor pressure of the each component of solution, that is solute and solvent, is less than the vapor pressure as expected according to the Raoult's law. This means the partial vapor pressure of the solution decreases than the solute and solvent. If we draw the graph for the partial vapor pressures, then the graph shows magnitudes of partial vapor pressures with respect to their mole fractions is slightly less than the expected by the Raoult's law. Conditions for negatively deviated solution. Condition number 1, PA less than P naught A XA and PB less than P naught B XB. That means the partial vapor pressures decreases as expected by the Raoult's law. Second condition, the enthalpy change becomes negative. That means energy is released, the solution becomes exothermic. Third condition, delta V equal to negative. That means volume of the solution also decreases. Some example having negative deviations are acetic acid and pyridine, chloroform and acetone, chloroform and benzene, water and hydrochloric acid, chloroform and ethoxyethane, water and nitric acid. In negatively deviated solutions, the intermolecular force of attractions of the solution becomes stronger than the intermolecular force of attractions of solute and solvent. Due to the increase in force of attractions, the solution have greater boiling point than the solute and solvent.